Hello and welcome to lesson 9-3. This one is jam-packed with information, so I might have to do it in two separate videos, so just be aware of that. This one is jam-packed. All right, here we go. Similar right triangles. Well, first we need to talk about something that's called the arithmetic mean. Okay, and you guys have been doing this where you talk about the mean of things. So if we have 16, what is the geometric mean, arithmetic geometric mean if we have 16 and 24? Basically, what that means is what number is dead smack in the middle of 6 and 24. So, how do we find that? Well, it is 15. So, 6 plus what, and what plus, so 6 plus 9 gives you 15, and then if you go 9 plus 15 plus 9, so from 15, if you go 9 one way, we get to 24, and if you go 9 the other way, we get to 6. So the number that is dead smack in the middle is going to be 15. All right, so you guys know how to find the arithmetic mean or average of two numbers is we add them up and divide by 2. So if we take 6 plus 24 and we divide by 2, we get 15. Okay, so that's the arithmetic mean. So what if we were talking about the geometric mean? So geometric means if we're going to be multiplying. So what would be the geometric mean of 6 and 24? So same numbers. Different thing, but now we're saying it's 12. Okay, so if we take 6 times 2, we get 12, and if we take 12 times 2, we get 24. So that is the number that is between the two. Okay, so multiplying by 2. All right, so how do we find that? What we say, and this is the main thing what we're going to be talking about in this unit, this lesson, is going to be the geometric mean, is the positive square root of their products. So take any two numbers, A and B, product means we're going to multiply them together, and then you're going to take the square root of that. So let's see how that works here for 6 and 24. So if we take 6 times 24, multiply them together, and then take the square root, is that what gets us to 12? Well, 6 times 24 is 144, and now the square root of 144 is 12. Okay, so there are 3 different ways that we write that. So one is what I just did, A times B, then take the square root. That's going to probably be the most common one. Now, what happens if we square both sides of this? If we square both sides, you end up with x squared equals, and here the square and the square root will cancel. So that's how we get the second one, or of x squared equals AB. Now, we can also take this. Where did that x squared come from? Well, we can go to a proportion, and so the only way to get x squared is to have one on top and one on the bottom, and then a on one side and b on the other side, so that when we multiply these together, we get x squared, and multiply these together, we get ab, which is what we've been working on in chapter 8, were proportions. So in chapter 8, we set everything up like this, like a proportion, and then we cross multiplied. So when we cross multiply, we get to this, and the next step from this of solving this would be taking the square root of both sides, and that's where we end up with this. So that's how all 3 of these are tied together. All right, so let's try some sample problems here. Oops, it skipped my samples. Okay, so here are 3 sample problems. So you go ahead, stop the video, pause it, and then you go ahead and find these, and then leave this in radical form. All right, so I'm going to run through these. So I'm going to do them all the same way. 9 times 16, take the square root. 4 times 5, take the square root. 1.5 times 12, take the square root. So these are all set up to kind of use that first way. So 9 times 16 is 144. So this gives you 12. 4 times 5 is 20, and that's why we say simplest radical form. So this is root 4 times root 5. So we get 2 root 5. And 1.5 times 12 gets us 18. So that is root 9 times root 2. So we have 3 root 2. So that's how we find the geometric means. Multiply them together and take the square root. All right, on to the next thing. So draw a right triangle, label the vertices A, B, and C. Using the hypotenuse as a base, draw an altitude of that triangle and label that D. So start with the right triangle. So we start with the big right triangle, A, B, C, D. Then they say draw an altitude. So I'm going to the hypotenuse. So if we start here at A and draw in the altitude here, we end up with 3 different triangles. The big one, ABC, the pink one, and the yellow one. Well, let's look at that big triangle, ABC, the big one. Does the big one have a right triangle? And is angle C in the big triangle? Now look at the pink one. In the pink one, do we have a right angle? And do we have angle C? So can we say that the big triangle is similar to the pink triangle? Okay, now we're going to do the same thing from the yellow triangle. The yellow triangle has angle B and a right angle. The big black one has a right angle and angle C. So can we say that the big triangle is similar to the yellow triangle? Well, if the big one is similar to the pink one and the big one is similar to the yellow, aren't all 3 of them similar? Okay, they are all similar triangles. Okay, so given that all 3 triangles are similar, can we write proportions? Okay, because they're all right. They all have a hypotenuse, they all have a short leg, and they all have a long leg. Okay, so let's look at this first one here. Oh, we're going to do something else first. So if this was a rectangle, can we find out what A and B are? And in this one, we can't find out because it would be A times B equals 36, and we don't know what A is and we don't know what B is. But what if this were actually a square? So these 2 sides were the same length. Can we set up x squared equals 36 and take the square root of each side? And now, do we know that each side is 6? Okay, so now let's get into this triangle. So we're talking about the ratio of a short leg to a long leg. Okay, short leg, long leg. So if we do the red triangle, short leg over long leg. Okay, red triangle, that short leg looks like it is A, and the long leg in that triangle is X. All right, then let's go to the blue one. So now if you go to the blue one, and let's pick that short leg, that's X, and the long leg is B. Now, we can also do the black one, which is what they do here. So the black one, the short leg is Y, and the long leg is Z. But if you look what I have right here, isn't that a geometric mean, what we showed back on the beginning? So that when you multiply this together, don't we get x squared equals A times B? So every time you have a right triangle with this altitude coming down, we can find out if we know what this altitude is x, we can set up x squared equals this part times this part. So x squared equals A times B. Okay, so that's using the ratio of the short leg and the long leg. All right, so that's what this screen is actually going through, and then we end up with x squared equals A times B. All right, let's go to the next one. And what are we doing in this one? So now let's look at the ratio of the short leg to the hypotenuse. So let's start with that red triangle again. Okay, start with the red triangle. And we're going to do short leg over hypotenuse. Okay, the short leg here is going to be A, and the hypotenuse is Y. Okay, now let's go to the blue triangle, and the short leg is X, and the hypotenuse is Z. Now go to the big triangle. Okay, the big triangle, the short leg is Y, and the hypotenuse is going to be A plus B. So nothing in common with this one. So this time we're using the red triangle and the big triangle, okay? So it would be like the red and black triangle, and we are setting up short leg over hypotenuse. So look what happens. Do we get a geometric mean again? So we take y times y squared equals, and then we're going to take A times A plus B. Okay, so now what I say when I do this is taking a leg and squaring it, and it equals the part of the hypotenuse, times the whole hypotenuse. Okay, so you can see the part A times the whole thing, A plus B. Okay, so that's using the red triangle and the big black triangle. Okay, y squared equals A times A plus B. All right, so now in this one, they're going to use the long leg times the hypotenuse. So in the last one, it was the red triangle and the big thing. This time it's going to be the blue one and the big thing. And we took leg squared. Well, let's see what happens here. If we take leg squared is going to be Z squared equals, and then we took A times the whole thing. Well, now we're doing it from the other side, the blue side. So do you think this one's going to be B times the whole thing, A plus B? So do you see how they're exactly the same? The short leg and long leg are exactly the same, just on opposite sides. So let's see if that's what happens. In the red triangle, long leg is X, long leg, over hypotenuse, Y. Okay, blue triangle. If we take the long leg is B over the hypotenuse, Z, and then the black triangle would be our long leg is Z over the hypotenuse, A plus B. So see, when we cross multiply, we get Z squared. So again, it is leg squared. And then you're going to take B, which is the part of the hypotenuse, and then the whole hypotenuse. So part of the hypotenuse and the whole hypotenuse. Okay, so that is what we get for our theorems. Okay, x squared is this times this, and the other ones are leg squared equals the part of the hypotenuse times the whole hypotenuse. All right, I only have 1 minute left, so we'll see if I get this in. Okay, what can we set up here to solve? Actually, I think I'm just going to do a new video, and I'm going to start with this sample problem so I can take my time and explain it. Okay, so we have all the theorems. I'm going to do one more video that's going to actually go through this sample problem for you.